Nutribake Syndion Berhad is a food biotechnology company that produces high-fiber probiotic bread. Our product combines dietary fiber and beneficial microorganisms to promote better digestive health. The company applies fermentation technology and follows GMP and HACCP requirements to ensure food safety and product quality. Our objectives are to produce safe and high-quality bread, maintain hygienic manufacturing conditions, and achieve customer satisfaction. The company consists of 5 key personnel. The CEO oversees overall operations, while the production manager supervises the bread production process. The QC officer ensures compliance with GMP and HACCP requirements. The microbiologist monitors yeast fermentation, and the technician operates production equipment. Our mission is to deliver nutritious bread products while maintaining high food safety standards and continuously improving product quality.
I will present the introduction of our case study on industry bread production. Bread is the one of the most widely consumed fermented food product in the world. It is produced using Saccharomyces cerevisiae, also known as baker's yeast. Based on previous studies, fermentation plays an important role in improving bread texture and flavor. Yeast activity also contributes to proper dough development and product consistency. The production process consists of several stages, including mixing, kneading, fermentation, proofing, baking, and packaging. This stage must be carefully controlled to ensure product quality and safety. Thank you.
This slide shows the process description and equipment used in bread production. The production process can be divided into upstream and downstream processes. The upstream process focuses on preparing and developing the dough. It begins with raw material receiving, where ingredients such as flour, yeast, sugar, and water are inspected and weighed. The ingredients are then stored under suitable conditions before being measured according to the formulation. Next, the ingredients are mixed and kneaded using an industrial dough mixer to form the dough. The dough then undergoes fermentation and proofing, allowing yeast activity to produce carbon dioxide and increase dough volume. The downstream process starts after the dough has been developed. The dough is divided and shaped into uniform portions before baking in an industrial oven. After baking, the bread is cooled to prevent moisture condensation, then sliced and packaged hygienically. Finally, the finished products are stored and distributed to customers. Overall, the upstream process ensures proper dough development, while the downstream process ensures the bread is processed, packaged, and delivered with consistent quality and safety.
Okay, today I will present about bioproduct plan layout based on safety level 1, 2, 3, and 4 and GMP requirement. So, for the first zone, we have zone preparation. This is where raw ingredients like flour arrive and get mixed, and it operates under standard basic safety rule BSL1. For second zone, zone fermentation, the dough is divided and allowed to rise. This area use special air to control to manage humidity for the yeast. For zone 3, zone baking and testing, the dough is baked in large ovens, which acts as the main step to kill bacteria. People must pass through airlocks and food baths to enter. So for zone 4, zone packaging, this is the cleanest area. Workers must wear full protective gear to keep the baked bread perfectly safe from contamination before it is shipped out. Air and waste control, the facility use advanced air filter to keep the air clean and autoclave to safety sterilize to and dispose of waste. So for general rule of this plan layout, the entire factory relies on smooth, easy to clean, wash-free hand washing and metal detectors to ensure food safety. For the process flow layout, we have 4 stages: receiving and storage, B, preparation and fermentation, and C, baking and cooling, and D, packaging and dispatch. For the personnel flow layout, we also have 4 zones: zone dry ingredient and dough preparation, zone 2 dough fermentation, dividing and proofing. For zone 3, we have baking, cooling and quality control, and then for zone 4, slicing, packaging and distribution. And we also can see in this slide we have production plan layout with a material flow. Also have 4 zone and it's same, and just this zone control the material flow. Through our plant-wide assessment, we classify potential hazard into 3 major categories: biological hazard, chemical hazard, and physical hazard. To ensure absolute safety, we pass 3 hazards to the HCCP's decision tree and identify 2 critical control points. CCP1 is overbaking, which serves as our definitive thermal kill steps to eliminate all pathogen in the dough. CCP2 is inline metal detection. Positionally after packaging, it acts as our final technological barrier to capture and isolate metallic hazard for dispatch. The operational management of this CCP relies on strict critical limits. For CCP1, the bread must reach a minimal external core temperature of 85 degrees every 2 hours. Any deviation requires immediate quarantine and complete destruction of the batch. For CCP2, we enforce a zero tolerance standard for metal fragment. The system is tested hourly using certified test fair to ensure perfect functionality.
This slide shows the plant layout of Nursery Baked Sdn Bhd, a food biotechnology company producing high-fiber probiotic bread. The facility is designed according to Good Manufacturing Practices, or GMP, to ensure food safety and efficient production. The production process begins at the raw material receiving and storage area, where ingredients are inspected before use. The materials then move to the processing area for weighing, mixing, kneading, fermentation, and dough shaping. Next, the dough undergoes proofing and baking in the baking area. After baking, the bread is transferred to the post-bake zone for cooling, slicing, and packaging under hygienic conditions. Finally, the finished products pass through the quality control before being stored and distributed. The one-way production flow helps prevent cross-contamination and ensures product quality throughout the manufacturing process.
For the biological hazard risk assessment, several potential contamination risks were identified throughout the bread production process. During raw material receiving and preparation, contamination may occur from mold spores or spore-forming bacteria such as Bacillus cereus present in flour and grain-based ingredients. There is also a risk of reduced probiotic viability before production begins. The highest biological risk occurs during fermentation and proofing. If temperature, humidity, or fermentation time are not properly controlled, wild molds and pathogenic bacteria may grow, affecting both product safety and quality. Another critical stage is baking. Insufficient baking temperature or time may allow harmful microorganisms to survive in the final product. After baking, the bread is exposed during cooling and handling. At this stage, airborne mold spores and improper personal hygiene can cause post-baking contamination. Based on the assessment, fermentation and proofing, baking and cooling and post-bake handling are classified as high-risk stages and therefore require strict monitoring and GMP compliance to ensure product safety.
For risk assessment, chemical and physical hazard we are identified during bread production. Chemical hazard may arise from cleaning agents, residues, or contamination from processing equipment. These contaminants can affect product safety and reduce product quality. Physical hazards include metal fragments from machinery, packaging debris, and all other foreign objects that may accidentally enter the product during processing. If not properly controlled, this hazard can lead to product contamination and pose health risks to consumers. Therefore, proper cleaning procedures, equipment inspection, and quality control measures are important to minimize these risks. Thank you.
I will present about personnel flow. Regulated entry and one-way movement. Employees enter through a designated entrance following a strict one-way traffic to maintain hygiene and prevent cross-contamination. hygiene and sanitation protocol. Workers proceed directly to the changing area and sanitation station to put on required protective safety gear. Designated zone access. One sanitize. Staff move straight into the assigned production zone based on daily operational requirement. So for control area transition, movement between different sections of the facility is tightly regulated, particularly when entering high care or clean zone like the packaging department to minimize contamination risk. Standardized exit flow. At the end of the shift, the personnel exit the facility by adhering to a specific path that route them back through the changing area. Compliance assurance. This structure flows guarantees that the facility consistently align with good manufacturing practice and food safety regulation. Also for material flow, as we can see from this slide, we have organized transport and separation. The layout ensures control, logical movement of raw material, packaging supplies, and finished product to minimize cross-contamination and improve traceability. And receiving and raw storage, incoming raw material arrive at a dedicated receiving docks and are placed in designated storage zone until needed for production. Sequential work in progress flow. Material move through the production phase in a strict non-overlapping sequences, like mixing, fermentation, baking, cooling, and packaging. And direct packaging supply. Packaging materials are delivered directly to the packaging section as required, preventing unnecessary handling in earlier processing zone. Finished goods and outbound shipping. Complete products are transferred to a dedicated finished goods storage area and dispatched through a separate distinct shipping dock. And last, operational benefit. Maintaining this strict physical or procedure separation between raw, intermediate, and finished good, optimize inventory management and uphold high food safety standards.
To ensure both food safety and strict regulatory compliance, we utilize a proactive risk management framework built on FMEA risk matrix and target HACCP system. Through this methodology, we identify two critical high-priority vulnerabilities that demand absolute control. First, on the biological front, second, on the physical front. To eliminate these threats, we implemented two definitive critical control points or CCP. CCP1 is our oven baking process. By continuously logging core temperature data, we guarantee the precise thermal legibility needs to destroy pathogenic microbes. CCP2 is our inline metal detection located just before packaging. This scans 100% of product flow, automatically rejecting any unit containing metallic hazard. Supporting this final defense and facility-wide operating control, we enforce strict environmental zoning, use HEPA-filtered positive air pressure to prevent airborne mold during cooling. Furthermore, our upstream quality assurance program vets suppliers so that raw fiber and probiotics are pre-certified before entering the facility.